Now that we've laid out all the necessary mathematical framework, we can finally begin doing some physics. And we're going to begin with kinematics in one dimension. Now, kinematics is the field of physics that studies how objects move, and the word kinematics can be loosely translated as how objects move. And in kinematics, more precisely, we study how the objects move without worrying about what the causes of that motion are. We will see later on when we study dynamics that the causes of those types of motion are in fact the forces that act on the system. More precisely, in kinematics, given the initial conditions of the system, that is, the initial velocity, initial position, and the acceleration, we are able to predict where the system will be and how the system will move at some later time t. The first two concepts that we're going to study are those of the distance and displacement. Distance is going to be the first one, perhaps because it's the most obvious. And the distance traveled by an object is measured by measuring the path along which the object moves, and it's always a positive quantity. It's generally measured in units of length such as meters, kilometers, miles, or centimeters, depending on the scale of the system. And for instance, if we have an object moving along this path here, with the initial position on the left and the final position on the right, the total distance here will be equal to the length of the curved path that joins those 2 points. Now, to describe the motion in a systematic way in one dimension, we need to use a coordinate system. That is, we need to use a set of axes that can describe the motion precisely at every instant. In one dimension, we deal with either horizontal or vertical motion, and therefore we use either the x or the y-axis to describe this type of motion. And generally, using what we learned from math, we use, say, a horizontal axis in which we label one point as being the origin, and we choose one direction to be positive and one direction to be negative. Following the mathematical notation of the real number line, we're going to choose moving to the right to be positive and moving to the left to be negative, as in the picture here. Before we get to describing displacement, we actually have to define the position of an object. And the position of an object is always measured relative to a reference point, which in general we can always choose to be the origin of the coordinate system. And position itself is a vector quantity. For instance, if I label the origin to be the center of my real number line, and the object is initially at this position here, let's label it x initial, then the position vector that describes the position of the object relative to the origin will be a vector that goes from the origin to that point there, and it will be labeled x initial with an arrow on top. Notice the difference between the two. Xi here, it's not a vector, it's the coordinate of the position of the object at this point. Xi with an arrow on top represents the vector that describes the distance of the object from the origin. Those two things are related, but they're not the same thing. Once we have a definition of position, we can then define the displacement. And the displacement is defined as the change in position of the system. Displacement is also a vector quantity, being the difference of two vectors. And the definition, the mathematical definition of displacement is as a change. So is delta x is equal to the final position minus the initial position. This definition here is irrelevant of whether the object is initially at a negative or positive position. It's just the difference of the final and the initial. For instance, if the object is initially at this point here, and this is the initial position vector x initial, and it's later on at some other time at this position here, then the position vector for the final position will be a vector that goes from the origin to that final position there, and the displacement vector will be the difference of these two, which hopefully you can clearly see that this one here And this here is delta x, which is x final minus x initial. So essentially, this is just the difference of two vectors, just as we learned previously when we studied trigonometry. So if I wanted to describe this vector here, the vector will be this one here. The green one, which is the difference of the two vectors. There are two very important points to be made about distance and displacement. Displacement, being a vector, can be both positive or negative depending on the direction of motion and depending on the values of the initial and final position. Distance, however, is not a vector because it doesn't have a direction. Distance is only the length traveled to go from one place to another, and therefore it's always positive and can possibly be different than the displacement. So the key point here is that displacement and distance, though might sound the same, they're not the same thing in physics, even though in everyday language we use these two words interchangeably. Let's look at one example that hopefully will make that clear. Consider the following. A person runs along a 5-mile straight track. If the person runs to the end of the track and back to their initial position, what are the distance covered and the displacement undergone by the person? So in this case, we have a person who runs along a 5-mile straight track. And one way to describe this again will be to draw a real number line. And let's put the origin a little to the left now. And we're going to choose the positive direction as usual to be to the right. And let's say that this is the 5-mile mark. Now, if the person runs from the origin to the 5-mile, it will go like this, and then the person comes back to its initial position. So let's look at the distance first of all. Well, the distance traveled clearly is 5 miles going from 0 to 5 plus another 5 miles going from 5 back to 0, and therefore the total distance traveled clearly is 10 miles, which is non-zero. However, what is the displacement in this case? Well, initially the person at time t0, say, is at the location x0, and therefore the initial displacement is 0. What about the final? Well, the person starts at the origin, goes to 5 miles, but then comes back and is again at the 0 mark. So the change in position, known as the displacement, is x final minus x initial, which is 0 minus 0, which is just 0. So clearly, even though the distance is positive, the displacement is 0 because it's the 0 vector. Another way of saying this is to say that the person starts and ends at the same point. And when this happens, the total displacement is always 0. So this is an important point to take home for future studies for when we talk about velocity and acceleration. Let's look at a more interesting example now. A plane, initially 23.2 kilometers to the east of a control tower, is flying west in a straight line, so that sometime later is 41.4 kilometers west of the tower. What is the displacement of this plane? Take the east to be positive. So again, we're taking the same definition that moving east or to the right is positive and moving west is negative. So let's label things clearly. We have a straight line. We have an origin here somewhere in the middle. And we know that the initial position of the plane is 23.2 kilometers east. So the plane is somewhere here. This is the initial position of the plane. And therefore, the initial position vector is this one here, and the length is clearly 23.2. At some time later, the plane will find itself to the left of the origin because it's moving west, and it's at a final position of 41.4 kilometers, which I'm labeling to be negative because by convention we chose left of the origin to be negative. And therefore, the final position vector is this one here. Now, the total displacement, and this is where you have to be careful with the signs, will be x final minus x initial. Now, x final has a length of negative 41.4 kilometers. From that, we subtract 23.2 kilometers, and therefore the total displacement is negative 64.6 kilometer. The reason why the displacement is negative is because it's the difference of these two vectors here, which essentially is going to be a vector of this length that points to the left. Now, you can check for yourself that the total distance traveled is equal to the absolute value of the displacement, which is in fact a positive distance. So once again, distance and displacement are not the same thing, and they shouldn't, because distance is a scalar quantity and displacement is a vector quantity. It happens in this case that the total distance traveled equals the absolute value of the displacement. But as we saw in the previous example, that's also not always the case. In the next videos, we're going to apply all these concepts to the study of speed, velocity, and acceleration.